Hi, we are now looking at section 2.3, getting information from the graph of a function. So there are several things that you can get from the graph of a function. So first thing is domain and range. Now, when we did the examples with equations for finding domains, so we were able to find domains, but with equations, it's not that easy to find the range. But with graphs, both domain and range are more visible or can be easily found. So what do we do in order to find the domain? We look for x values because the domain are the x values. So along the x-axis we see which values of x have a point on the graph. So that all those values will be in the domain. So in this case, for example, first picture, so you look at the graph, so you can see the x values from the beginning point. Let me call this A, this point over here, and the ending point B. So then you can see that all these values between A and B, and including A and B, we have points on the graph. Therefore, the domain in this case will be the closed interval AB. Now, if this was a whole, I hope you guys should know that then the domain would have been A, comma, B, parentheses, because the point B is not included. Okay, so let's go back and check what is the range. So for the range, we look at the y values. So now we will be moving on the y-axis. So smallest value is over here. Let's call it C. And the largest value or the highest value will be here. Let's call it D. Oh. So we call this value D. Then the range is, you can say the range is D. So range is CD. Okay. Another thing that you can get from the information from the graph is where is the graph, where is the function increasing and function decreasing. So if you look at this example in the second second picture of the graph, so it's starting at the point A and going up to point F. So these solid points at the end are telling you that where it is starting and where it is ending. I have corresponding points to the A, B, C, D, E, F, corresponding X values down there, little a, B, C, D, E, F. So if we, how do we check whether the function is increasing or function is decreasing? Well, if you feel like you have, let's say you have a graph, something like this. So what you need to do is pick a point somewhere on the left side with the of the graph and have it and move on the graph. So let's say I start somewhere here well, I should be starting, from down below, like in this graph, we will start at A. But anyhow, so if this is what just as it is, the graph is just as like this. So you can start anywhere here, because we assume that this is just going down, 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 down. So in starting any point, so start moving on the graph from left to right. So as we move like this on the graph, the horizontal distance is being traveled in this direction, which is what we want. So, but when we move on the graph, it feels like we are going uphill until we reach a point over here. So all this time we felt like we were going uphill. So this will be, you will say, function is increasing from negative infinity to whatever this x value is. X value of this point will be, okay. So, and if you feel like you are going downhill, like from the next step, you will notice that from here to here, it feels like you are going downhill. But then again, from here up, you feel like going uphill. Okay? So uphill is when your graph is going up, then the function is increasing. When the graph is going down, the function is decreasing. Okay, so coming back to our graph now, let's see where is it is increasing and where is it decreasing. And once you understand this, then without moving on the graph, you can tell. So we start at A and we move on the graph, feel like moving uphill, uphill, uphill until we arrive at B. So the x value corresponding to the B point is the little e, and the x value corresponding to the point A is little a. So we see that increasing on so the first interval we have is A to B. So on the interval A to B, which is here in the x along the x-axis, so we say that this is increasing on this interval. Then when is increasing? It's increasing from in this portion as you move from the point C to the point D. So corresponding points on the x-axis are little c and little d. So we'll say union C, D. And then we see again from E to F, it is increasing. So we say union EF. So now note one thing here, EF. And let's look at decreasing. So decreasing on. So decreasing is when you feel like we are going downhill. So for example, from B to C, you feel you are going downhill, and from D to E, you feel you are going downhill. So decreasing on BC interval, union DE interval. Now note here, I am not including these endpoints in the interval. The reason is because at the end point, when we are up here at B, we are neither decreasing nor at a place which is neither decreasing nor increasing. So you cannot include it in any of these. So it means the point, what is happening at B, it is neither increasing nor decreasing. So that's why the little b is not included in the same way the other points. Anyhow, okay, so now you should be able to see and tell where the function is increasing, where function is decreasing. Now these points, these bumps and I don't know, normally we call these peaks, peak. So these are peaks. This one and this one. And this type of points, these are called valleys. So the peaks are something that we call local max values, and then valleys are something we call local minimum values. So local maximum and local minimum. So what do we mean by that? By that we mean that in the neighborhood of that point, so for example, let me blow it up, the B and the C condition. So this was the point B and this is the point C. So in the neighborhood, just very close to, now we know that there is another peak coming close by, but, and this was the D, I believe. So we look at in the neighborhood of the B, like this much. If you look at all the values, height, all the y values for these within this interval, they are smaller than the y value at B. That's why this point or this y value is called so local max, local maximum or local max. And in the same way, this point at D, the y value is called the local max. So a graph can have more than one local max and more than one local mins. So we call this as local max. And then this valley type point, this we call local min. And again, why local min? Because if you go in the neighborhood, let's see this neighborhood. So if you check all the y values, the value at C point is the minimum of all the y values. So that's why it's called the local minimum value. Okay, so that's it. So look at this now, graph. So what is the domain here? Okay. So looking at, so here you can see the domain in this case is so it's a -1 to 4. What is the range? Range is the, so this is the minimum value and this is the maximum value. So it is -1 to 2. Okay, where is it increasing? Increasing on, so you can see from here to here, right? But when we don't say -1 to, well, 2, okay, because we are not giving the y values, we have to give the x value, increasing on 0 to 2. Okay, And where is it decreasing? So decreasing on, it is decreasing from -1 to 0. Union, also it is decreasing from 2 to 3. Okay. Where is the function constant? So you see that between 3 and 4 there is a horizontal line. So it is constant on the interval 2 to 3. Sorry, 3 to 4. So this is how you should be able to extract information from the graph. Now note here this second picture that I drew. I just wanted to show you the difference. Like over here in this picture that we were just looking at, these are end solid dots, so it means it starts here and stops at this point. So, but if you are given just a graph which has no solid endpoints and the line is just left somewhere in between, then you have to know that that means that the domain will be negative infinity to infinity. Looking at the next example, the graph of a function h of x is given below, and we have to work out these problems. Find h of -4. So h of -4 will be equal to, I can actually, I think I will write it over here, it's more clear. H of -4. So we have -4 is over here. So we go, the graph is down below. So this is the value, y value that we are looking for, h of -4, and we estimate looking on the y-axis, the value is coming somewhere in the middle of 3 and 3.5. So let's call it 3.25, or if you want to call it 3.2 or 3.3, that's fine. Okay. So you can, because this is online, so you can blow it up if you want. So if you look now, so it's exactly looks like in the middle of this box. So which means 3.25. Okay. What about next? Okay, I was writing it over there, but h of -2. -2 is, so it was -3.25. Oh my god. So h of 2, so we look at the graph. The 2 is over here. Okay, h of -2. So -2 is over here on the left, and it is height is between 1 and 2, so 1.5. So h of -2 is 1.5. So I'm just going to, I think, put them here. What is h of 1? Well, 1 is over here, and this is the value just a little bit above the 0.5. So let's say 0.6. H of 3. H of 3 is over here, and the graph is passing through the middle of this box. So it will be 0.5. H of 4. So this is 4, and the value is over here. So h of 4 is 4. Then it says find the domain of the function. So you can see it is coming from because of these arrows. So if there is an arrow or no arrow, that means it's coming from negative infinity on this side, left side, and this means it's going to positive infinity. Okay, so the negative infinity to infinity. So the domain is the whole number line. So negative infinity to infinity. What about the range? The range of the function, because we see it's not going down, 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 down forever, but it's going up, 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 up forever. So its upper value, the domain will be infinity. Lower value is the minimum value of the function, which we found to be over here. So the range will be negative 3.25 comma, what is this? Negative 3.25 comma infinity. Okay, so then next problem is asking find the values of x for which h of x is equal to 1. So h of x is the y value. So it's saying when y value is 1, what are the x values? So which x values map onto 1, or which one is taken or by which x values. So what you should do is, if you cannot see them directly, then draw a horizontal line crossing the axes at 1 and read the x values of the points where the horizontal line crosses your graph. So h of x is equal to 1 will be h of x is equal to 1 at x equals. So first is this leftmost value. You can see if you draw vertical, so it's negative 4.5 or negative 4.6 or 4.7, someone says, and comma also over here. So you can mark the points before you start writing the values. So wherever this is crossing, so these are the 4 points at which it's crossing. Just now read the corresponding x value. So this will be negative 2.5. Then we have negative 1, negative 1 point. So this will be negative 1.3 or 1.4. And then we have one more point, which is 3.2. And then we also have to check the values for h of x is equal to 3. So we do the same thing. At 3, we draw a horizontal line, pressing, and you notice it crosses the graph here, 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 and here. So we read the x corresponding values. So h of x is equal to 3 at x equals. Okay. So the first value is what? More like negative 4.8, comma 3.75. Then next will be 4.3, and then last one will be 6. So these are the x value, the function takes on the value 3. The next is saying find the values of x for which h of x is less than or equal to 1. So now this we already have a line drawn at x is equal to 1. So now we have to look for the values of x for which the graph is below the x-axis, below the line y is equal to 1. So you can imagine or you can assume that the portion above the line, above this red line is gone. Okay? It's gone. So our function will be less than or equal to 1 on so x values will now be intervals, will be given in intervals. So it will be starting at the first negative 3.2, sorry, negative 4.6. So negative 4.6. Now we will include this value because it says less than or equal to. So negative 4.6 comma negative 2.5 union negative 1.7 to 3.2 union. Okay, then that's it, because for the rest of it is greater than 1. So these are the intervals on which it will be below 1. Now we can do the same thing for 0 or any number. So for the values of x for which h of x is less than or equal to 0. So less than or equal to 0 means basically there the function is negative. So it will be negative below the x-axis. So you can see the points are going to be, so on the x-axis, just mark the points where the function is crossing the x-axis. So these are the points. So this will be below the x-axis between negative 4.6. No, actually here it will be 5. Negative 4.5 cannot be same as the previous one. Negative 0.5 to negative 3 union, then from 0 to 3. Okay, state the intervals where h of x is decreasing. Okay, so as you can see, the function is coming from negative infinity because we have it, there were arrows here at the endpoints. So negative infinity to negative 4 union, and 4 can be, so we don't include the points in the intervals for increasing, decreasing. Then it is decreasing again from -2 to 2. Or you can actually split this interval as, because there is and not include 0, -2 to 0, union 0 to 2 in place of -2 to 2. And then also decreasing from 4 to 5. Next state where it is increasing. So it is increasing from -4 to -2. Union 2 to 4. Union 5 to infinity. Give the local minimum and maximum values. So there are more than one local min values and more than one local max values. We say local min is equal to, the first local min is occurring at -4. So the value, because it says value, so we have to give the y values. So it is equal to -3.5 at x is equal to 4, -4. Then we have local min at, local min is equal to, the next local min is occurring at 2, and the value is -1.5. So -1.5 at x is equal to 2. And then we have another local min at 5. So it's a local min is equal to, at 5 value is 1.5 at x is equal to 5. And then local max. So local max equals, so the first, from the left side we see the first local max happens at -2 and its value is 1.5. At x is equal to 2. Then again local max is equal to, where does it happen? It happens at 4. So, and the value is 4. So this is how we can find the information from the graph. Okay, I think I'll stop here and do the next example on the next video.